Okay, section 6.6 is on the general form of the equation of the line. So this is the third form of the equation that we are learning now, and the first one being slope-intercept form, y equals mx plus b, and the second one being slope-point form, which was y minus y1 equals slope outside of x minus x1. And now we're doing the general form of the equation. And with the general form of the equation, all terms are on one side of the equal sign, and you have your equation is always equal to 0. And another thing you need to have is you have to have the x term first, then the y term, and then your constant term. And in addition to that, a has to be a whole number, which means that basically a is never negative. And b and c can be integers, which means b and c can be negative, but they still have to be non-fractions, so they have to be whole numbers that are positive or negative. Standard form is another form. We're not going to get into that too much, but basically it's very similar to general form, but it doesn't have the constant on with the x and y. It has a constant on the side by itself. But basically, if we go back just for a moment to general form, just a couple of things you just have to remember. For general form, there's no fractions. So think no fractions, there's no brackets, as there were in slope-point form. And the x term is always positive. And I set up here no fractions with decimals as well. No fractions or decimals. No brackets, and the x term is always positive. And all terms on one side. Equal to 0. Okay. So when it's in general form, sometimes it's a lot easier to find the x and y intercepts, because if you remember, to find the x-intercept, we're looking at the place where it crosses the x-axis, so we would be letting the y-coordinate equal 0, because every single point on the x-axis has a y value of 0. So for the x-intercept, all we'd have to do is take our equation, 2x plus or minus, 3 instead of y, we're going to put in 0. Minus 6 equals 0. And that's going to give you 2x minus 0 minus 6. Or 2x minus 6 equals 0, which means 2x equals 6. And then you divide both sides by 2. And you get x equals 3 is the x-intercept. Or, if you want to write it as an ordered pair, it would be 3, 0. And the y-intercept, you let x be 0, because the y-intercept is the point where the graph crosses the y-axis, so that means that every point on the y-axis has an x-coordinate of 0, so if you're looking for the y-intercept, it makes sense to let x be 0. So 2 times 0 minus 3y minus 6 is 0. So it's a nice easy form of the equation to work with because there's no fractions until possibly the end when you're trying to figure out, isolate the x or the y, but when working with it, it's nice easy numbers to work with. So we'll isolate the negative 3y, bring the 6 over, or add 6 to both sides, whatever way you want to look at it. And then divide both sides by negative 3. And you get y equals negative 2. Or as an ordered pair, that would be 0, negative 2. Okay, so now we're going to learn how to change from one form of the equation to the other. So the first one is given in slope-intercept form, and we want to change it to general form. And general form, if you remember, has no fractions. So that's what we want to get rid of, that fraction. So the easiest thing to do here would be to multiply both sides by 4, the denominator. So multiply both sides by 4. So that would give you 4y equals 4 outside of 3/4 x minus 5. And that would give you 4y equals, that's 12 over 4, because that's understood to be 4 over 1 times 3 over 4. And if you can do this step in your head, you can skip this step. So 4y equals 3x minus 5. So all we have to do now is bring all the terms to one side, but make sure that the x term is positive. So x is already positive on the other side, so I'm going to bring the 4y over. So I subtract 4y from this side and subtract 4y. Oops, not 5y, 4. Minus 4y. And then you just put them in the order 3x term first, so 3x first, then negative 4y second, and then constant. And then because everything is on the right and the x is positive and we want to bring it, usually we have the x and y and constant on the left hand side, we're going to basically turn the whole equation around. 3x minus 4y. We're not really bringing it all to the other side because we're keeping the signs the same, we're just turning the equation around, so that looks more like the general form. That was on the last page. So this one here, we start off with y minus 7 equals negative 2/3 inside of x plus 4. So again, you want to get rid of the fractions, so you're going to multiply both sides by 3, the denominator. So this is going to give you 3 outside of y minus 7 equals 3 times the negative 2/3 times x plus 4. So that's going to give you distributive property, going to give you 3y minus 21. And then this one here, you only need to multiply the 3, which is 3 over 1, times negative 2/3. Those 3's cancel, or you can think of it as negative 6 over 3. In either case, you're going to get negative 2. Either cancel out the 3's or multiply and get negative 6 over 3, which gives you negative 2. So then that's still outside of x plus 4. And then you have to distribute that negative 2 to get negative 2x, and negative 2 times 4 is negative 8. And then you bring all the terms to one side so that the equation is equal to 0. And you want the x term to be positive. So the x term of this time is negative on the right hand side, so we're going to bring it over to the left hand side where it would be positive. 3y is already on this side, so it's positive, so it stays positive. Negative 21 doesn't move, it's still on the left side of the equation, so it stays negative. But the negative 8 we're going to bring over to the other side of the equal sign, so it's going to be positive on this side. Or you can imagine adding 8 to both sides. And the only thing left to do now is put the like terms together, so 2x and 3y, and then negative 21 plus 8 is going to be minus 13 equals 0. So now we're going to try a few more examples. First one there is slope-intercept form, so we're going to double both sides to get rid of the fraction. So that's 2y equals 2 times negative a half is going to be negative 1 x, and 2 times 3 is going to be 6. So then we want to bring everything to one side. So the negative x comes over to the other side as a positive x. And you can put the 1 in front if you want. You don't need to, though. It's understood 1. 2y is going to stay where it is. And then you bring the 6 over. It's going to become a minus 6. Next one we're going to distribute. So it's going to be y minus 2 equals negative 4x plus 4. And then again, we'll bring the negative x term to the other side, so it's going to become a positive 4x. The y is already on this side, and it's positive, so it stays positive. You got your minus 2, stays minus 2 on the left side, but the 4 is going to come over to from the right side to the left side, so it's going to change to a negative 4 on the left side. So then you've got 4x plus y minus 6 equals 0, and your x term is positive, and you get in the right form x's, y's, and constants. Last one there, going to get rid of that 5, so I'm going to multiply this side by 5, and I'm going to multiply the right hand side by 5. So that's going to be 5 outside of 3 over 5 by x minus 2. So then that is going to be distributed to give you 5y plus 20. Multiply the 5 by the y and the 4. And this one you only need to multiply 5 by what's in front of the brackets, x minus 2. So that's going to give you 15 over 5, or cancel out those 5. So that's going to give you 3. And 15 over 5, if you did it that way, would still be 3. And then you have to distribute the 3. And you get 3x minus 6. And again, 3x is positive on the right side, so I'm going to bring everything over to that side and then turn everything around after. So 3x. And then you've got the 5y comes over and becomes negative 5y. You got the negative 6 that's already there. And then the 20 is going to move over to the other side as a negative 20. So 0 equals 3x minus 5y minus 26. And again, you can turn the whole equation around and write that as 3x minus 5y minus 26 equals 0. Technically, you can think of it as bringing everything over and changing the sign and then dividing by negative 1. But when you've got it, when you've got the right thing you want but the wrong order, just it's like turning the whole thing around. So you don't have to go through all those steps. Determine the x and y intercept of the line with the equation 4x plus 2y minus 16 is 0. So the x-intercept remember we let y equal 0. So that's going to give you 4x plus 2 times 0 minus 16 equals 0. And that's going to give you 4x plus 0 minus 16. I can skip this step if you want. Which is going to give you 4x minus 16. So then if you isolate the x, 4x equals 16, and then divide both sides by 4, you get x equals 4. And then to get the y-intercept, let x be 0. So then you've got 4 times 0 plus 2 times y minus 16 equals 0. So that's going to be 0 plus 2y minus 16 is 0. And then that's going to be 2y. Isolate the y term. equals 16, and then divide it 2. And you get y equals 8. So if we plot those points, x is 4 and y is 8, we can sketch our graph. It says verify the graph is correct by writing the equation in slope-intercept form and checking the slope and the y-intercept. So we take our equation, and isolate, because y equals mx plus b form. That's what we want. The slope-intercept form, so we want the y by itself. So we're going to bring the x term and the constant over the other side. So that's going to become a negative 4x on the other side and a positive 16. And then we want y, not 2y, so we're going to have to take that and divide it by 2. And whatever we do to the one side, we got to do to the other. So we got to divide everything on the other side by 2. So that's going to give you y equals negative 2x plus 8. And if we go back and check, that means our slope from the equation is negative 2, and the y-intercept is 8. Well, we know the y-intercept is 8 on our graph, and from our workings in A. And if we check the slope between two nice points on the graph, which is going to be hard for my graph because the line is so squiggly, but it is 2. If you go from here down 2, and then negative 2, down 2, and then right 1, you're going to get a negative 2 over 1, which is a slope of negative 2. Oops. Okay, question 3. Determine the slope and y-intercept of each line given, and then plot both lines on the same grid. So the first thing we're going to do is isolate the y. So bring the x term over to the other side. It becomes a positive 3x on the other side. And then the positive 20 becomes a negative 20. And then you want to divide everything by 4. So that's going to become y equals 3 over 4x minus 5. So your slope is going to be 3/4, and your y-intercept is going to be negative 5. So you plot your y-intercept and then count slope 1, 2, 3, 1, 2, 3, 4. Then up 1, 2, 3, and right 1, 2, 3, 4. And there's the first line, and we'll call that A. And then the second one, negative 3y. Isolate the y term, bring over the x term, becomes positive 5x on the other side, and minus 21. And then we want to divide everything by negative 3. So it's going to give you y equals negative 5 over 3x plus 7. So the slope would be negative 5 over 3. Oh, that's an awful 3. That's not a bad, is a bad 5 too. And the y-intercept is 7. So 7 is your y-intercept, and then your slope of negative 5. So down 1, 2, 3, 4, 5, and then right 3. 1, 2, 3. And down 1, 2, 3, 4, 5, and then right 3. 1, 2, 3. I didn't do a very good job. It's hard to write with this. I'm going to make that worse. Anyway, you got the idea. Okay. Okay, question 4. How can you tell if the two lines are equivalent? By now you should realize that basically you should have them in the same form. So it's going to be hard to change general into slope point form because you need to know some points on the line, and it's kind of be a little bit more work to do, but write both of them as slope point form. So we can, though, easily write the slope point form as general form. The other option is to write both of them in slope intercept form if you want to do that. So we're going to write both equations in the same form. So that would be either general form or slope-intercept form. So either write them both in slope-intercept form or change the slope point form so that they're both written in general form. And we're going to use general form. So y minus 4 equals 2/5 x minus 5. So I need to multiply both sides by 5 to get rid of that fraction. And that's going to give you 5y minus 20 equals, that's understood to be over 1, so that's 10 over 5, or cancel out your 5s, so it's going to be 2 either way. And then that's 5y minus 20 equals 2x minus 10. And then I'm going to bring everything to the side where x is already positive, so that'd be 2x. Bring over that 5y is going to be minus 5y. And then you've already got a negative 10 there, and you're going to bring over that negative 20 as a positive 20. So then you've got 2x minus 5y plus 10, or 2x minus 5y plus 10 equals 0. So therefore, they both represent the same line. So they both have the same general form, therefore are equivalent. As I said, the other option is to change both of them to slope-intercept form. We don't have enough room to show that way. Okay, the last question is just kind of like a little challenge question, and it's writing the general form equation, rewriting it into slope-intercept form so that you can find the slope and the y-intercept. So because we don't know what a and b and c are, we're going to end up with a formula for finding the slope. So what we do, and the y-intercept, so what we do is change this to slope-intercept form. Because that's what we're trying to find, the slope and the y-intercept, so it makes sense to change it to the form where you can read the slope and the y-intercept off the equation. So we're going to bring the ax over the other side, so it's going to become negative ax, and we're going to bring the c over, so it's going to become negative c. And then we want to divide out the b, so that's going to give you y equals negative a over b x minus c over b. So if we look at that, that would mean that the slope would be negative of whatever a is over b, and the y-intercept would be the negative of whatever c is over b. So for example, just to show you that, so for example, if you had 2x minus 3y plus 6 equals 0. If you knew those formulas, the slope should be negative a over b, which means it should be the negative of 2 over the b, which is negative 3. So that would be 2/3. And the y-intercept should be the negative c over b value, which would be negative 6 over negative 3, which would give you 2. But realistically, you don't have to memorize those formulas, because all you have to do is change that to slope-intercept form and you'll get those things anyway. So these are some questions for you to try now on material from this section on pages 384 to 385 of your textbook.